Hello my dear learners, welcome to my video lectures on energy sources. In this session, I will be talking about properties of steam. A brief introduction about me, I am Shamant, I am working as an assistant professor at Global Academy of Technology. If you want to reach me or if you have any queries, you can mail me at shamant@gat.ac.in. In my previous video lecture, I have spoken about the formation of steam. While I was explaining about the formation of steam, you have understood clearly the conversion of the water into steam. So how exactly the water which was taken at 0 degrees Celsius was converted to the state of boiling or evaporation, and it reached the temperature which is Ts. It is nothing but the saturation temperature, and from there it was converted to a dry steam, and then it was taken further to a superheated steam. So to understand the formation of steam, there are specific terms that you need to understand, and also there are some properties that you need to remember, and these properties will help you out in solving the numericals based on the formation of steam. Okay, so there are certain properties which are very much important. I'll explain you one by one. The first property that you need to understand is dryness fraction. For every steam, when it starts to boil at point B, it has to be converted into a dry state from a wet state. So we have understood there are three types of steam. One is a wet steam, one is a dry steam, and then superheated steam. So the steam, until it reaches the dry state, we call that steam as wet steam. So we need to identify what is the wetness of that particular steam. How much percentage of the steam is dry, how much percentage of the steam is wet. For that factor to identify, you will use dryness fraction, and dryness fraction is defined as the ratio of mass of dry steam which is present in a known quantity of wet steam. So when you know the quantity of the wet steam, then you can find out what is dryness fraction to the total of the mass of wet steam. So here the dryness fraction is given as X, it is denoted by X. It is defined by the ratio of mass of the dry steam present in the wet steam. It is in the numerator, you have to take the mass of the dry steam present in the wet steam to the mass of the wet steam, which is written in the denominator. And when you take this ratio, you will get one value, and that is the percentage of dryness. Okay, so in short, you can write it as mg. Mg is nothing but the mass of the dry steam divided by mf plus mg is nothing but the mass of the wet steam. So where mg is the mass of dry steam, mf is nothing but mass of the suspended particles. So for example, if you take 1 kg of wet steam, okay, if 1 kg of wet steam contains 0.9 kg of dry vapor, then you say dryness fraction is 0.9. So x value ranges from 0 to 1. The dryness fraction ranges from 0 to 1. For wet steam and for dry steam, x is equal to 1. So that means if x is equal to 0, that means the water is completely wet, or it is still in liquid state, it has not converted into a vapor state. Okay, when x is equal to 1, the steam is completely dry, or it has been completely converted into vapors. Water has been completely converted into vapors, and that is when we call it as dry. Okay, so x ranges from 0 to 1. You need to find out what is that particular dryness fraction. Okay, so this is the range where we actually take the dryness fraction of the steam from B to C. If the steam is at B, then you say x is equal to 0. That means the steam is wet. If it reaches the point C, then x is equal to 1 because the steam is totally dry. Beyond C, it is completely dry, it is at a superheated state, so we do not consider that phase of steam. We only consider the dryness fraction in the range of B to C. Now here you can just see a couple of problems just to make you understand what is dryness fraction. The first problem says determine the dryness fraction of steam if 2 kg of water is in suspension with 80 kg of dry steam. So here you have you have given with the wet steam, that is mass of the wet steam, that is mf is equal to 2 kg, and then 80 kg of dry steam is taken, mg is equal to 80 kg. So now you have to find out the dryness fraction from this. How to find out the dryness fraction? X is equal to mg by mf plus mg. So now just substitute you get the value as 0.975. After simplifying, you get the value as 0.975. It means to say that the steam is 97.5% dry. 97.5% dry or 2.5% wet. That is what the dryness fraction means. Now another problem here for you to understand, 10 kg of wet steam. So how much is the wet steam? Wet steam is taken as 10 kg. It contains 1.75 kg of water particles in it. Okay, 1.75 kg of water particles in it. What is the dryness fraction of the steam? So total mass here is 10 kg. Out of that, mass of water particles is given as 1.75 kg. You need to take the difference of that. That will give you mass of the dry steam present. It is 10 minus 1.75, which will give you 8.25 kg of dry steam present in the 10 kg of wet steam. So now dryness fraction, just substitute the values. Mg is nothing but 8.25 and Mg plus Mf, it is the total mass of the steam. That is 10 kg, it will give you 0.825, or the quality of steam is 82.5% dry. You can say it has 82.5% dry or 17.5% wet. That is what the use of dryness fraction is. So to find out the quality of the steam, it is very much important to understand the dryness fraction. The next property which is very much important is sensible heat. Sensible heat, as I told you while explaining about the temperature enthalpy diagram, it is the water which is required, it is the heat that is required to raise the water from 0 degrees Celsius to saturation temperature Ts at a given pressure. So it is denoted by HF. So what is sensible heat? Sensible heat is the amount of heat required to raise the temperature of 1 kg of water from 0 degrees Celsius. This 0 degrees Celsius means that water is at point A. From point A to point B, if you want to increase the temperature of the water, the amount of heat whatever is required, that is called as sensible heat, and that is denoted by HF. And now if the sensible heat, or if the water has reached the saturation temperature, then there is some heat which is being applied to the water or exerted on the water so that it has reached saturation temperature or the point at which water has started to boil. At that point, you call it as sensible heat. Now, moving on further, the next property is latent heat of evaporation, and that latent heat of evaporation is nothing but from point B to C. You are now considering point B to C, and it is the amount of heat required to convert 1 kg of water. Here you are specific to the quantity of the water. You have to take 1 kg of water only. The amount of heat required to convert 1 kg of water at the saturation temperature. That is, we are talking at the point B. Okay, so to convert 1 kg of water at the saturation temperature Ts to 1 kg of dry saturated steam at the same temperature Ts and at a given pressure, it is denoted by HFG. So if you look at the temperature enthalpy diagram, so if you look at this diagram, HF is denoted here in this region. This is the HF region from A to B. So sensible heat says it is the amount of heat required to raise the temperature of water from 0 degrees Celsius to Ts degree Celsius. That is called as sensible heat. It is denoted in this region. And then latent heat of evaporation is denoted by HFG. That is what we learned. And that says it is the amount of heat required to convert water at Ts, at this particular point, water at Ts degree Celsius into completely dry saturated steam at point C. Okay, in the same pressure and same temperature. That is called as latent heat of vaporization, or you also call it as latent heat. The next property is superheat. Superheat is the amount of heat required to raise the temperature of dry saturated steam. So now the steam is completely dry at point C. Now the amount of heat which is required to raise the temperature of that steam above its saturation temperature. So above its saturation temperature and at a given pressure is known as superheat. And the process of heating the saturated steam above its saturation temperature is called as superheating. And likewise, you have to calculate the degree of superheat also. The degree of superheat is defined as the difference between the superheated temperature and the saturation temperature Ts. So degree of superheat is given by CPS is equal to TSUP minus TS. So that is what the degree of superheat is. The next property we will be talking about is enthalpy of steam, enthalpy or total heat. Whatever we saw in the previous slides, that is HF or HFG, they are all the enthalpy of the steam or total heat. So the total heat is defined as the sum of internal energy, that is represented by U, and the product of pressure P and volume. It is denoted by H and expressed in kilojoules per kg. Enthalpy H is equal to U plus PV. It is denoted by U plus PV. Enthalpy of steam is the amount of heat energy contained in a unit mass of steam. So you are all, while calculating the enthalpy, it is always for unit mass of steam. If you are taking kg, 1 kg of steam is only enthalpy is calculated for. Now enthalpy is different for different types of steam. It does not remain the same for a wet steam, for a dry steam, as well as superheated steam. It changes. And what are the formulas that we need to use for different types of steam? So keeping this enthalpy formula common, that is H is equal to U plus PV, we will see what is the different formulas for different types of steam. Very important formulas here you need to note down. Enthalpy of a dry steam is given by Hg. Hg is equal to Hf plus Hfg. It is nothing, Hf is nothing but sensible heat plus Hfg is nothing but the latent heat. So all this enthalpy is represented in the temperature enthalpy diagram. I'll just show you. Enthalpy of the wet steam. Okay, Hg is nothing but enthalpy of a dry steam. H wet is nothing but enthalpy of a wet steam. It is given by Hf plus X into Hfg. Hf is nothing but sensible heat, Hfg is the latent heat. But why are we introducing X term here? We are introducing X term because it is the wet steam, the enthalpy of the wet steam that we need to calculate, and we need to know how much percentage the steam is wet. So that is why we involve or introduce X, and that X is nothing but the dryness fraction. Okay, the next type of enthalpy is superheated enthalpy, HSUP. We denote it by HSUP, and that is given by enthalpy of a dry steam plus the enthalpy of a superheated steam, that is CPS into temperature of superheated steam taken the difference with the saturated temperature. Now, while you are calculating enthalpy and when you are taking the superheated temperature as well as saturated temperature, you have to take it in terms of degrees Celsius only. Please remember this. While you are taking the values of superheated temperature and saturation temperature while calculating enthalpy, it should be in degrees Celsius only. Specific heat can be taken as 2.25 kilojoule per kg Kelvin by default. Even if it is not given to you, you have to take it as 2.25 kilojoule per kg Kelvin. I hope you have understood what exactly is the enthalpy. This is how the enthalpy is represented. Enthalpy of a wet steam is represented by Hf, and if you want the enthalpy of a dry steam, you are calculating by the Hg. Hg is equal to Hf plus Hfg. Okay, so starting from B, we start to calculate the enthalpy. Okay, so if you want the enthalpy of a wet steam, then Hg is equal to Hf plus X into Hfg. That is what we calculated there. So we have introduced X term. If X is equal to 0, then Hg is equal to Hf, which is nothing but enthalpy of the region A to B. Okay, if there is some percentage of wetness in the steam, if it has crossed B, then you have to introduce X value. If X is 0.2, then it says that it is 20% dry, okay, or 80% wet. So you have to take X value, then calculate Hg value. That is the enthalpy of a dry steam. And then HSUP is nothing but enthalpy of a superheated steam, which is given by Hg. This term Hg plus the amount of superheat, it is CPS into TSUP minus TS. When you add that, then you will get the HSUP, which is nothing but enthalpy of a superheated steam. The next property is specific volume of a steam. So specific volume of a steam is defined as the volume occupied by a unit mass of steam at given temperature and pressure. So while you are heating the water which is contained in the cylinder fitted with piston and the weight W which is kept over the piston, there is constant pressure being acted on the water. But upon heating, what happens to the water? It will not remain in its position. It has to change its position, right? It starts to expand. So this specific volume gives you what is the volume occupied by that unit mass of steam at given temperature and pressure. At 0 degrees Celsius, the specific volume will remain Vf, okay, because it was the initial volume of the water. But upon heating, upon certain temperature, if you have to calculate by what amount the volume has been increased in the cylinder, then you have to use this property to calculate that, and that is always expressed in terms of meter cube per kg. So specific volume again is not same for the different types of steam. Wet steam it is different, dry steam it is different, and superheated steam it is different. You have to introduce the dryness fraction there and then calculate the specific volume. So now the density of the steam is vice versa of the specific volume. It is just the inverse. It is the mass of the steam per unit volume of steam. Okay, density is mass of the steam per unit volume, whereas specific volume was volume occupied by unit mass of steam, okay, at given pressure and temperature. It is the reciprocal of the specific volume. Density is given by rho is equal to 1 by V. V is the specific volume of the steam, and V changes. If V is wet steam, then you have to take V as x into Vg. Okay, you have to consider x into Vg because you have to introduce that dryness fraction and then calculate the specific volume of the wet steam. If it is dry steam, take Vg. Vg is nothing but the volume of the dry steam. And then if you want superheated steam, if you want to calculate the density of a superheated steam, density is equal to 1 by V SUP. So here you will see the formula for calculating the specific volume. Specific volume of saturated water is given by Vf. Specific volume of a dry steam is given by Vg, and it is nothing but dry steam is Vg, where x is equal to 1. If x is some value, then you have to take specific volume is equal to x into Vg, where x is the dryness fraction. Okay, x you have to take it as dryness fraction. And then specific volume of a superheated steam is Vg multiplied by the ratio of saturation temperature, the superheated temperature to the saturation temperature. So this will give you the specific volume of a superheated steam. The next property is external work of evaporation. External work of evaporation is when conducting the experiment, when you keep on heating the water, there is some heat absorbed, and that heat is latent heat. And a part of the latent heat which is absorbed by the water is used by the piston and the weight which is acting on the water to raise up. Okay, so that is called as external work of evaporation. When water at the saturation temperature is heated at constant pressure, it gets converted into steam by absorbing the latent heat. Okay, so it has to absorb the latent heat, and then only it can convert into steam. If it does not absorb the latent heat, it cannot convert into the steam. It remains in water as the phase of liquid. What happens is, now after absorbing the heat, a part of this latent heat is used to move the piston due to the increase in volume. So there is increase in volume in the substance what is kept inside the cylinder, and that increase in volume moves the piston above. Piston again is exerting a constant pressure on the water, but still the amount of heat whatever is absorbed is utilized in converting the distance of the piston from one position to another during the evaporation. So this work done due to change in volume of the steam from Vf to Vg is called as external work of evaporation, and this external work of evaporation is given by 100 multiplied by the pressure and the volume of the dry steam in terms of kilojoules per kg. So this is the formula to calculate external work of evaporation if the steam is dry. If the steam is dry, you have to take it as Vg. If the steam is wet, then you have to take it as x into Vg. So that is what you have to consider, and you will understand what is this external work of evaporation in the during solving the numericals. So you can just see here how the external work of evaporation actually comes into picture. So at the beginning, the piston and weight W is acting constantly on the water, and now upon heating further, gradually it has increased its position. See here, it has increased its position to here, and to here. How did this position change? This position changed because of the external work being done on the piston and the weight W kept on the piston by the increase in volume inside the cylinder. So this is called as external work of evaporation. I already explained you, for a dry steam, it is 100 into pressure into Vg is nothing but the volume of the dry saturated steam. If it is wet steam, you will be taking 100 P into X into Vg. So this X into Vg comes into picture because of the dryness fraction in it. X is nothing but the dryness fraction. And then you have to calculate, if you have to calculate external work of evaporation for a superheated steam, then it is 100 into P into VSUP. VSUP is nothing but the specific volume of a superheated steam. So all these value, whatever I am telling you, that is Vg or it might be HF, HFG, it is all available from the steam tables. You will be understanding that when we solve the numerical problems. When I explain you about the numerical problems, you will understand that thoroughly. So the next important property of the steam is internal energy. So this is said to be the last property of the steam that you need to remember. And the internal energy is the difference between the enthalpy of the steam and the external work of evaporation. So the actual heat energy stored in the steam, is known as internal energy of the steam. And it can be obtained by subtracting the external work of evaporation from enthalpy of the steam. Why are you taking a difference between enthalpy of the steam and external work of the evaporation? Because external work of evaporation says it is the part of the heat which is absorbed for the movement of the piston. Okay, there is some amount of energy lost. Okay, so that is why if you want to calculate internal energy, you have to take the difference of enthalpy of the steam, that is the energy contained in that particular steam, taking the difference with what is the energy which is used to do the work. Okay, so that is how you will get the internal energy, and it is always the difference of enthalpy of the steam and external work of evaporation. Say for example, you are calculating internal energy for a wet steam, then you are taking enthalpy of the wet steam. Okay, H wet. You will be taking enthalpy of the H wet minus the external work of evaporation for a wet steam. Okay, W wet. So if you take this, then you will be getting internal energy for a wet steam. UWET is nothing but H wet minus W wet. Similarly for a dry steam as well as superheated steam. So this is how you calculate the internal energy. So here are the formulas to calculate internal energy of the steam for different types of steam, as I explained you in the previous slide. So for a dry steam, you represent it by UG. UG is equal to Hg minus 100 into P into Vg, where this is nothing but the enthalpy of a dry steam and this is nothing but external work of evaporation of the dry steam. Similarly, even for wet steam and then for superheated steam, if you want, you can just go through, you can pause it and then copy down the formulas. So this is all about the properties of the steam. There are a few important properties that I have explained it to you. If you like this lecture, share it with your friends, like it, and then do subscribe. Thanks for listening this lecture patiently. Thank you very much.